I had a question like, uh, here is the temperature in Fahrenheit, right? And here is the calculation in degrees Celsius. It's like 9/5 times Fahrenheit plus 32. And it asks about your mean, and then it asks about your standard deviation, right? Up, JK, other way around. Okay, so Fahrenheit, Celsius, good. Okay, now to do the mean, all you're going to do is take what your original mean was, plug it in, right? Yes. So if I said 70 set, this is in Celsius. If I say 32 is my mean, I'm going to plug that in and get my new mean. Good. If I say the standard deviation was, let's say 10, I'm going to plug the 10 in, but I'm not going to add the 32. Why am I not going to add the 32? You don't add or subtract to standard deviation. You only multiply and divide. Okay, why?
Because of the table that we put in our notes. There's like a bar and some deviation. So it's still the same ratio. It's just that there. We adjusted.
Yes. So if I say, hey, I'm going to move my numbers and add 10 to them, that didn't change my variability. It just moved the numbers up. Does that make sense? Okay. Not the hum. Not the hum. All right. Go ahead and check the rest of your work. I'm going to scroll down. Okay. We love when technology does not work. All right, on three. Three should be fairly symmetric. Yes. Okay. The mean and standard deviation of this one is going to be 32.13 for the mean. The standard deviation is going to be 1.23. Everybody okay? So we're on number three. Okay. Why did you what? Because I posted those up on the board. Yep. How much of an outlier does it need to have in order to make it skew? Like talking about this one specifically? Okay, look at the standard deviation. Okay, where's our mean really quick? 89.7 right here, right? Okay, look at our standard deviation. Oh, up 2. So what's 89 plus 2.2?
91.2.
Okay, 91.2. So that's like right in here, right? Okay. And then add another standard deviation. So 91.2, add 2.2. Okay. And then add 2.2. 2. That's going to be like right in here, right? So this is within 1, 2, 3, 4 standard deviations. So it's within that normal curve. Does that make sense? I'll say no. Oh, okay. So when you look at normal curves, you kind of want to think how spread out is it? And maybe just add that standard deviation to it so that you can see how far away from the mean is it. Now, if it's outside of that realm, then yes, it's going to be skewed. 4 plus. Yeah. Good. Okay. All right. Look at number 4. All right. On number 4, calculate and interpret the z-score. Some of you on your quiz were like calculating the z-score and then going to the table when the question just asked you to find the z-score. Okay, so the z-score should have been 0.75. Okay, now what does this mean? Can you interpret it? What does this mean? So Patrick Mahomes' quarterback rating is 0.75 standard deviations above the mean of 54.37. Good? Okay. All right. Describe the mathematical operations used to calculate the z-score for Patrick Mahomes. So what do we do first? Subtract the mean. Then what? Then divide by standard deviation. Oh, that's pretty easy. You just use the formula, right? Okay. Suppose that we converted all 30 of the quarterback ratings into z-scores. What would be the shape, mean, and standard deviation of the z-scores?
The mean will be 0, the standard will be 1, and so will be normal.
You're taking a guess.
Okay, well, I didn't see answers.
Okay, yep.
With zero being infinite, and then zero being choice.
I was like, you have a picture of that?
So, okay. So right now we have a mean 54.37, right? If we converted everything into z-scores, would it have any outliers? Okay. What if you actually graph this? Did you try graphing this? Did you try graphing this? Okay, make like a box and whisker. That's probably going to be the easiest to see. So take a moment, put this on a box and whisker. Okay, so on your box and whisker, is it normal or is it something else?
It's approximately.
So there could be an argument for slightly skewed left, very, very slightly, because look at this. This tail is a little bit longer. Yes, my graph is a little bit janky, but it's slightly skewed left because this one's longer than this one is. There's also like a bigger box on this side of your box and whisker. Yeah. Okay, so we can say slightly skewed left. Okay, now could you maybe make a argument for approximately? Maybe. All we're doing is when we're converting it to z-scores, we're just making it smaller numbers, making it manageable numbers. Okay. All right, let's go ahead and take a look at number 5. Okay, so calculate the z-score. What'd you get for A? Nobody got to number 5? No? Do we need a minute? Okay, try it. Just because it's on my mind. Cumulative relative frequency charts. There's a question on your test that asks you about IQR, okay, of the cumulative relative frequency. When you are given this, you need to find like how much percent is each section. Does that make sense? Like each corner. So like from here to here is 10%. From here to here is 30. And help me because my eyes are bad. 40 to here is 20. And this should be about 10. This goes into like 5. I don't know about 15. Look at it again.
I mean, what was that?
This one's like About 10. Okay, but it doesn't matter. Because what about IQR? What is IQR? 75% minus, does everybody understand why? Okay, right. So 25% is going to be roughly in here, which is going to be 4. If I scroll down, it would be 4. Okay. And then finding 75%, that would be about in here, up here. So that's going to be about 14. Okay, so at 14 minus 4, that's where it's going to give me 10%. Does that make sense? Yeah, I haven't put it in context. I'm looking at the numbers. Does that make sense? That's IQR. I know these cumulative relative frequency charts are not so much fun. Okay, good. All right. All right, going back to number 5. Get over. All right, on number 5, what'd you get? 2.42. Okay, say it again. It was 24.57. Okay, so on this one, you should have gotten 2.42 for the z-score. For the next one, you should have gotten 24.57 feet. Thank you. Okay. The points right there. Mean is what? Mean is 23.616 or 23.62. That's okay. That's okay. You're fine. And then standard deviation, what is that going to be? Okay. Does everybody understand how to get there? You got it? Okay. I was like, yes. All right. Calculate the z-score. What'd you get? 2.42. What do you notice? Because it's the same as what we got up here, right? So it's the same as when our units were measured in meters. Remember, the z-score really shouldn't change. Even if you're going from like feet to meters or whatever, it shouldn't change. Still be the same spread. We okay? Okay. Want to try 6, 7, 8, 9? Okay. Really quick. I would probably get like a piece of paper or go to your chapter 2 note and like there's some blank paper in there. So that way you can kind of take some notes. If I ask a question like, if I say the 10th percentile in a normal distribution is 15 and 2.5% of the values in the data are greater. Okay, I'm on the wrong screen. Thank you. Appreciate it. Ghost Rider, it's fine. Okay. Are greater than 35. What would be the mean? And the standard deviation for this group. Okay. If this was a multiple choice question, how would you go about doing If they told you what the mean was and the standard deviation was, like how could you check which one was correct? What would be the fastest way to do this one? Plugging in, what do you mean? Okay. So for instance, this 2.5% tells me that if I draw a normal curve, okay, I know that it's going to be greater than 35, and that's at that 2.35% and above, right? So whatever the mean is that they give me, because 2.35 is right here, and then 0.15 is right here. It's that next section over on the normal curve. Yeah. Okay. So then I would take whatever the mean is, check it, and make sure that the standard deviations make it so that that happens. Okay. I would also check the other side. I would do the 10th percentile, which is 15. Okay. So how would I figure out where that's located at? So if it's at the 10th percentile, and I'm telling you that the number is 15, so the value is 15, it's somewhere over here, right? How do I figure out where that's at on my normal curve? Okay, so you could check it that way. So on your table, you would look for 0.10 inside the table, find the corresponding Z score on the outside, right? And that would tell you how low it is from the mean. Does that make sense? Okay. This is almost kind of a distractor. If this is multiple choice, I would use this as my like indicator. That would help me. Yeah. Okay, so that's one question. Okay. I would give you answer choices and then you would go from there, which I'm not going to do that for right now. Okay. All right. Next thing, we talked about IQR. Okay, and cumulative relative frequency. Okay, so how do you find this again? Okay, and whatever that number is. If I say the distribution of time it takes to, let's say, write a novel is skewed to the right, or let's say to the left, and the mean is, let's say, 5 days. And the standard deviation, I'm just making these numbers up, so don't judge, is 1.25. What would the distribution for z-score look like? What would that look like? The distribution for z-score. First of all, what's going to be the mean now? 0. What's the standard deviation going to be? Okay. And will it hold the same shape as the original? Yes. So if it's skewed left, what is it going to be? Skewed left. Does that make sense? I'm sure question. Okay. So the mean would be 0 and the standard deviation would be 1. We would still be skewed left. Cool. Let's put a pause. If I said, tell me what the z-score is closest to the 52nd percentile, would you do that? Go to the table. Okay, so everybody look at your table. And what am I looking for in the table? Okay, so I'm going to look for 0.2. And what's the corresponding z-score? What's the corresponding z-score for 52nd percentile? Look at it again. So looking at my z-score table, I got 0.05. Yes, no, no? Am I crazy? What? Okay, so are y'all looking at the numbers on the side to get that? Okay, no. Look in the table and you're telling me the z-score. So you're going to tell me the numbers on the outside. So do it backwards. Okay, I'm glad we had this discussion. Go in the table and find the closest thing to 0.52. So that's going to be like 0.5199. And what's the corresponding number for z? 0.05. So the z-score is 0.05. Everybody see that? Okay, don't mix up z-score with the proportion / percentile. Okay. I'm asking for the closest z-score to the 52nd percentile.
Oh.
Yeah. Everybody okay? Okay. Okay. If I was asking something similar to what you did on that quiz, okay, if I said that the mean reading of temperature is 33 degrees Celsius, and I tell you that the formula for Fahrenheit is 1.8 times degrees Celsius plus 32. And I tell you that the standard deviation is 0.1 degrees Celsius. Tell me what would be the new mean and the standard deviation. How would we find that? Okay. Okay. So to find the mean, I would take 33 and plug it into the formula. To find the standard deviation, I'm only going to multiply 0.1 times 1.8. Good? Okay. All right, let's chat a little bit about density curves. Not a fan. I don't like them. They're lame. Okay, if I had a density curve and it looked like this. Oh, let's do it the other way. If it looked like this, and I told you A, B, C, where would the mean most likely be located? Where would the median most likely be located? Okay, would mean or median be lower? So mean is going to be greater and the median is going to be lower. So median would be this guy and mean would be this guy. If it was the other way, so like let's say that it was skewed left. Oh yes, that's a terrible drawing and it's off the page. Hold on. Let's say it looked like this. where would your median be? It would be at C-ish. Are you sure? Okay, remember, we want it to be like about halfway, so my lines are a little janky. Hold on, pause, pause, pause. Okay, does that look a little better? Okay, so where would the median be? C-ish, okay? And then B would be the mean. Okay, but remember, the median is going to be at like kind of like that half mark of the curve. Okay, again, my picture is a little janky. Cool. It's not going to be like super close to the top. It's going to be like in that middle curve. Good. Okay. All right. What do we know about normal distribution curves? Okay. Normal distribution. Okay. What about the area under the curve? Oh, no, 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 no. The area under the curve equals 1. It equals 1, right? Because all of those proportions are decimals, right? Or 100%. Yes. Okay. Um, that's it. That's all I want you to remember. Area is 1. Okay, cool. Good talk. Huh? So then your whatever your mean is. Yeah, all that jazz. Yep. Okay. Okay. Your FRQ portion, it is a lot like most of the questions that we've went through today. If I ask for a proportion, what am I asking you to do? I need you to find the z-score, go in the z-score table, find whatever the decimal is, right? Okay, give it to me in decimal. You know how to find an outlier.
Yes.
Okay. Yes. Remember 1.5 times IQR, and you're either adding it to Q3 or subtracting it from Q1. Do you know how to calculate z-score? Can you interpret the z-score? Can you determine the percentiles for something? Okay. I think you'll be okay. If you did not finish your recommended assignment, get your life together. If you didn't do the practice test, probably would be a good idea. Okay.